Solution Stoich is just like the other forms of Stoich that we've looked at before. We just have to add one concept, and that's the concept of concentration, molar concentration. C is equal to N over V, where N is moles divided by V, which is measured in liters. So we have to be aware that we're going to be looking for concentrations in moles per liter. These concentrations will allow us to determine the moles or determine the volume. We're going to use an example to show you how we work through it. What volume of 14.8 moles per liter ammonia is needed for the complete reaction of 1.00 megaliters of 12.9 mole per liter phosphoric acid to produce fertilizer NH4,2HPO4. So start by writing the balanced chemical equation. NH3 aqueous plus H3PO4 aqueous reacts to produce NH4,2HPO4 aqueous. We need to balance this chemical equation, and we can see that we have two nitrogens on the right hand side here. So we need to have two nitrogens on the left hand side. We put a 2 in front, and then we check our hydrogens. I have 6 hydrogens from that and 3 more to make 9. Here I have 4 times 2 is 8 plus 1 more makes 9, and I still have my PO4, so everything is balanced. Now we need to find our given and wanted information. Our given information is always going to have a measured amount, like 1.00 megaliters of 12.9 moles per liter phosphoric acid. That would be my given amount. So I write that down. Concentration is equal to 12.9 moles per liter, and volume is equal to 1.00 megaliters. Wanted information is the one that has given something but not everything we need. So 14.8 moles per liter of ammonia. Concentration is equal to 14.8 moles per liter. We want to know the volume. We set this up just like we've set up all our other Stoich equations. We go to the given amount and we look for the measured amount of given. So that's the 1.00 megaliters of H3PO4. And we are going to multiply by something to get rid of those liters and replace with moles. And this is still of H3PO4. And so that's our concentration. 12.9 moles is what it says over 1 liter. So 12.9 moles over 1 liter. Now I have to use the mole ratio, and I'm going to replace moles of H3PO4 with moles of NH3. And my mole ratio from my coefficients is 2 moles of NH3 to every 1 mole of H3PO4. Finally, I have to replace moles of NH3 with volume of NH3, which would be liters of NH3. And that is my concentration again. Now, this says 14.8 moles over 1 liter. So 1 liter and 14.8 moles. I get my calculator out and I the solution, which turns out to be 1.74. Now I have to figure out what the units are. So I look and I say, okay, I have liters here and here, those cancel out. I then have moles of H3PO4 there and there, those cancel out. I have moles of NH3 there and there, those cancel out. What do I have left? I have mega and I have liters of NH3, which is what my final answer should be measured in, megaliters, and we can keep that subscript there of NH3. Don't forget your statement answer. It should go something like 1.74 megaliters of NH3 is needed for the complete reaction of 1.00 megaliters of 12.9 mole per liter phosphoric acid. I'd like you to try this lab exercise on your own. Have a read. I want you to calculate the predicted amount of precipitate, and then I want you to do percent yield and percent difference calculations. So take some time to go through this and practice it, and I will post the solution to the classroom page on a separate set. The rest of your practice comes from your workbook, questions 28 to 40. Good luck.